Welcome to my channel. Today we are going to discuss about diversity techniques. So, what is diversity? As we already know, any transmitter transmits a signal to the receiver. But when the signal transmits via the channel, it gets faded by multipath components. Hence, we do not receive a good signal at the receiver. In order to overcome this problem, we go for diversity technique. In case of diversity, what we generally try to do is we try to improve the link. So, how do we do that? What we do is that we send the multiple copies of the same signal from the transmitter side. At the receiver, we have multiple antennas to receive different signals. So, when these different copies of the same signal arrive at the receiver side, received by the multiple antennas, if one signal is faded, the other signal might not go severe fading. As a result, we can choose the best signal for the further processing. So by doing this, we tend to receive the best signal at the receiver. Another advantage of diversity is that when compared to equalizer, an equalizer needs a training sequence which is not required in diversity technique. The only thing required by diversity technique is multiple antennas at the receiver side. So there are two types of diversity. The first one is microdiversity, and the second one is macrodiversity. In case of microdiversity, what we try to do is we try to overcome small scale fading. Whereas in case of macrodiversity, we try to overcome large scale fading due to obstacles and shadowing. First, we are going to discuss about microdiversity. So, basically, we are going to overcome the effects of small scale fading. As we already know, in case of microdiversity or in case of small scale fading, whenever a person moves slightly from the particular place where there is a heavy fade, we tend to get a good signal. So, in order to get a good signal, if we just move a small distance, we can get a very good signal. So, in case of microdiversity, there are different methods such as spatial diversity, temporal diversity, frequency diversity, angular diversity, and polarization diversity. So, in case of spatial diversity, what we actually do is we use several antenna elements which are separated by space. So we can see that in case of spatial diversity, if we consider this particular example, here we have two antennas which are separated by 5 to 10 wavelengths. So when these two antennas receive the signal, assume that this is the first signal and this is the second one. If suppose the first signal is highly faded, the second signal might not be faded to that extent, and hence we can select this particular signal for further processing, hence improving the link. In case of temporal diversity, here also we can see that there are two antenna elements. The first antenna element will come at time slot 1 and the second antenna element will come at time slot 2. So in this case, if suppose there is a deep fading at and time slot 2 and the fading is minimal at time slot 1, then we can choose this particular signal and avoid this particular signal. Since we have this multiple copies of the same signal, it becomes easy for us to select the best one. Frequency diversity. In case of frequency diversity, the signals arrive at different frequencies and we can choose the best among these two frequencies. But the problem is that in case of frequency diversity, since we are using two or more frequencies for the same signal, the spectral efficiency will be reduced. So that will be the problem in case of frequency diversity. Angular diversity. In case of angular diversity, we can see that there are antennas with two different patterns, pattern A and pattern B. So when these two antennas receive the signal, they see two different signals. They receive, even though the same signal is transmitted at the transmitter, at the receiver, the two signals are totally different. If one signal is having a heavy fading or deep fading, the other signal might not have the same. Hence, we can choose the best among the two. In case of polarization diversity, we have two different polarizations. One is horizontally polarized signal, the other one is vertically polarized signal. So here we get at the receiver side, we receive horizontally polarized signal and the vertically polarized signal. Among these, we can choose the best signal. If a horizontal polarized signal has a better signal, we can choose horizontally polarized signal and reject the other one. So these are the classifications of microdiversity. So now we are going to see what is macrodiversity. In case of macrodiversity, we try to combat large scale fading. When does large scale fading occur? Whenever there is a big building or a hill and a mobile station goes around the building or around the hill, the particular mobile station faces fading for a very long period of time until it comes out of that building or the hill. Hence, in order to overcome this large scale fading, we use macrodiversity. So, in case of macrodiversity, if there is a hill between the transmitter and the receiver, adding antennas on base station or the mobile station will not eliminate shadowing. So, what we need to do is we can add a separate base station that can be placed in such a way that the hill is not in between the mobile station and base station 2. So by doing this, it creates a large distance between base station 1 and 2, thus trying to avoid shadowing. This gives rise to the concept of macrodiversity. Thank you.